Hello, welcome to Analog Art Data Recorder tutorial. Please feel free to download the demo application software from analogart.com to help you follow this seminar. For this presentation, we use a two-channel data recorder, one of the instruments of SL987. In this instrument, all the user controls unique to channel 1 are grouped in the channel 1 panel. Similarly, all the controls unique to channel 2 are grouped in the channel 2 panel. Besides these two panels, there are a timing panel, a data recording panel, and a utility panel. Each individual button in these panels allows the user to perform a unique task. Together, they control the various features of the data recorder. In order to illustrate these features, we first provide the real-life application. We connect channel 1 to a 2-volt 1 Hz cardiac signal with a 10x scope probe and connect channel 2 to the output of a temperature sensor through a coax cable. The data recorder originally resets to its default settings. Depending on the application, these settings might not be suitable. We must first choose the proper probe setting. Since we are using a 10x scope probe for channel 1, the 10x setting is appropriate. The green buttons adjust the vertical scale of the data recorder. The button marked with the up arrow increases the voltage range, whereas the button marked with the down arrow decreases it. With the 10x probe setting, the vertical scale can be changed from 20 millivolts per division to 20 volts per division. To have a better view of the signal, we adjust the vertical scale to 500 millivolts per division. The timing panel provides 7 text boxes, which enable the user to set the horizontal or the timing scale. The range of adjustment is from 500 nanosecond per division to 1 year per division for remote low frequency sensing. When timing is changed, the new value remains in red and it is not applied until the enter key is pressed. At this time, the screen sweep restarts. For timing scales of 1 minute per division or more, a new start time is updated in its location. 400 milliseconds per division shows a familiar cardiac display. Turning on the button labeled ground disconnects channel 1 input from the signal and connects it to the ground level. This is usually done to find and observe the ground reference on the screen. The yellow arrow on the right side of the screen indicates the 0 or the ground level. Be aware that each time the voltage scale is changed, the arrow resets back to the middle of the screen. The AC button blocks the DC content of the signal. AC coupling compromises low signal frequency analysis, as it does for the cardiac signal. Notice, for this exact reason, when the signal has low frequency content, AC coupling is not a good choice. Replacing the signal on channel 1 with different DC voltages has no effect on the plot in the AC coupling mode. However, switching back to the DC shows that the signal level is indeed changed. Removing the DC offset brings the signal to the middle of the screen again. For timing scales of 1 minute per division or more, each channel offers 3 extra modes of data acquisition. They're called maximum, minimum, and average. To review their operation, we apply a 500 Hz 3-volt sine wave to channel 1 and change the timing scale to 1 minute per division. The maximum mode is activated by switching on the button max. It captures the maximum value between two consecutive acquisition times and plots the signal in the button's color. Similarly, the minimum mode of operation plots the minimum value between the acquisitions. These modes of acquisition guarantee that sensitive data between two acquisition points is not lost. In the averaging mode, the average value of the data between two acquisitions is plotted. Each mode offers its own unique advantages and is suitable for certain applications. Let's review the signal on channel 2. This signal is the output of a temperature sensor. Since we are using a coax cable to connect the signal to this channel, the 1x scope probe setting must be used. Since temperature does not change rapidly, the sensor is stimulated with a 60 watts light bulb at a distance of about 2 inches. The light bulb would be turned on and off every few minutes. Therefore, the timing scale would be set at 1 minute per division. To have a good viewing range, the vertical scale of channel 2 is set such that every division would correspond to 5 degrees Fahrenheit. In addition, the DC position of channel 2 is adjusted to make the negative 600 millivolt DC level translate to about room temperature. The blue arrow on the right side of the screen indicates the 0 or the ground level for channel 2. Notice that channel 2 is showing how the light bulb temperature has varied during the past few minutes. It is clear at what times the light bulb was turned off and for how long it remained in that condition. Notice that the data corresponding to the position of the mouse is displayed near its position in each channel's corresponding color. Each channel also provides the user with a set of markers. These markers can be used to analyze the signals. The markers are turned on and off by clicking on them. The voltage difference between the horizontal markers are updated and displayed at the screen's top right for channel 1 and bottom right for channel 2 in their corresponding colors. There is also a set of timing markers. They are displayed by clicking the markers in the timing panel on. They enable the user to make timing measurements. The corresponding timing data is displayed at the left bottom corner of the screen. The position of arrows, signal, and markers can be changed by the mouse. To do this, left-click the mouse near the signal or the arrow, and while holding the mouse down, move it to the intended position and then release the mouse. With its wide range of timing adjustments, this data recorder is especially suitable for slow-varying signals. The acquired data can be saved in a text file. The sampling rate and also the data length can be specified in the corresponding text boxes in the data recording panel. For time settings of longer than 131 milliseconds per division, the data size can be up to 100 megabytes for each channel. For other time settings, a data length of about 1 second can be saved. The user is notified about how many data points can be saved. The saving process can be cancelled at any time by clicking the Cancel button. The button marked Load allows the user to load a previously saved data file. The utility panel on the top of the screen helps the user to perform a number of tasks. The Reset button brings the data recorder to its default condition. Button Save Plot enables the user to save the screen in a variety of formats. To recall screen plots, simply click on the Recall Plot button. The Calibrate button starts the self-calibration process of the data recorder. This process usually takes about 10 seconds to complete. The Display button hosts a set of features which enable the user to easily configure the display to his or her likings. They help the user to personalize the color of each channel, the color of the screen, the order by which the channels are plotted, and customize the screen grid. Clicking the Print button sends the data recorder plot to a printer selected by the user. Finally, the Help button guides the user to an online analog art information site that hosts a collection of user manuals, specifications, and useful application documentation and videos. We hope you have enjoyed this presentation. For any additional information, please send an email to info@analogarts.com.